Cool. Okay, next, I'm very pleased to introduce our speaker today, Chen. Chen Wang serves as a Senior Research Software Engineer, RSE, at the National Center for the Supercomputing Applications, NCSA, of University of Illinois Urbana-Champaign, with a background in environmental science, holding a BS and MS degrees in atmospheric science, along with another MS in bioenergy. Chen's expertise spans web application development, scientific algorithm implementation, and data analytics. She leads the development of the social media Macroscope and has made significant contributions to projects like the K-12 school reopening interactive playbook during COVID, supported by the Rockefeller Foundation, as well as ongoing initiatives including the NSF-funded Clouder and NIST-funded InCore. Proficient in Python, JavaScript, Java, and familiar with RESTful services, database design, container technologies, and AWS cloud computing. Chen is dedicated to harnessing her extensive experience to create impactful science gateways and research web applications, thereby expanding the accessibility of valuable scientific insights. Okay, with that, I will hand it off to Chen officially, and she will get started with her presentation.
Thank you. Thanks, Olivia, for introducing me, and it's my pleasure to be here to showcase this tool we developed called the Social Media Macroscope. Oh, sorry, technical difficulties. I don't see that on my screen, actually. And I don't see it on this screen either. Oh, sorry, I got it. Restart. Yeah. Thank you for being here. So the Social Media Macroscope is like actually a suite of tools to help you make sense of social media data. This is who we are. We're from the National Center for Supercomputing Applications, affiliated to the University of Illinois at Urbana-Champaign. And we also collaborate with external collaborator Joe from University of Pittsburgh. So why Social Media Macroscope? This has been an ongoing effort since like 2017. When we first started to develop this, we look at the landscape of social media analytics tools, and there are a lot of those. But they generally fall into two categories. On one hand, you have those commercial tools, have very nice user interface and very easy to use. Like, for example, if you're familiar with Meta has its own like business analytics like tools, and Instagram also have like insights to help you gain like aggregated data points of certain like features. However, how they actually come up with those metrics and how to gather the data and how to generate the analytics are all like very black boxed. A lot of our users are researchers and from academia. When they publish their research, it's very hard for them to cite or refer to those data generated by those platforms. But on the other hand, we have like extremely transparent ways to do your research, which is write your own Python or write your own R script. There are a lot of abundant of open sourced like analytics packages that you can leverage to scrape the data, to crawl the web, to perform like natural language processing and those kind of tasks. However, it is a little bit, it has certain barrier, like a researcher has to have some programming background to be able to use those tools. Okay. So user have to have certain training in, like, have certain computation background to be able to use those tools. But however, a lot of social media researchers, they're actually coming from a humanity or like social science background. To ask them to learn programming from scratch is kind of distracting them from their job. So we thought about those and like, why can we create something that position ourselves in the intersection of the ease of use as well as the transparency of methodology? So here we are. Yeah. There are other benefits. For example, right now to use the social media macroscope, it's completely free for academic use, versus if you have to use commercial tools, you usually have to pay thousands of dollars of subscription fee. And we also cater to academic needs. So a lot of our metrics are more research focused, versus those commercial tools usually are like catering to marketing or like brand, like analytics, those type of things. And lastly, because we're right next to a research institution, so we have the advantage of directly incorporate the research results without waiting for the full cycle of like publication, and then read the publication, and then get the data, and then trace back to how the data was generated. Yeah. So that explains our motivation. And so what is social media macroscope? So it's not just one tool, it's like a set of tools that we accumulate, like a portfolio we accumulate over the years, like an app store. Yeah. So we have 3 tools so far, and Smile is the one I will talk the most about tonight. It is the one comprehensive platform for social media data ingestion, analysis, as well as data sharing. And then we have BAE. BAE stands for Brand Analytics Environment. This is more specific, catering to brand personality. It can learn a user's tweets and then compare with a consumer brand's tweets, and see what's their correlation. And lastly, we have this SMM Clouder. It's a data management framework developed in-house at NCSA called Clouder, but we can customize it to suit for different domains. So in our case, we add a lot of plugins and features to create a SMM Clouder. Yeah. So this is our past usage data. So over the years, this tool has been used a lot for teaching. So it has been used for online MBA class at UIUC. So you can see we have like our peak, we have like about 4,000 users. Yeah. So now I'll share with you a little bit more about our tool Smile. So analyze it with a smile. Yeah, you can click this link to try it. You shouldn't be able to need to register anything. And I was gonna give a live demo, but live demo is too tricky. So I recorded. Yeah. Yeah, and I'll talk along with this. So this is our landing page. If you have any collaborative ideas, don't hesitate to reach out to us. And if you go to get start, and this will lead you to the 3 tools that we currently have. And if you click this, it will lead you to Smile. We named this playground because this instance is meant for public access. So all of your data will be kept only for 1 day in the system, but along the way, you can download your data. And so this is the main interface of Smile. It's a web application. And these are the features we have. And when you click Get Start, this is our paper references that you're welcome to cite us, to support us, or if you're using our tool to generate data and you want to publish with that, feel free to also cite us. And now you can log in. We used a plugin called CI Logon, which is also developed at NCSA. This thing will allow you to log in with your own like institution identity. So we just trust you as who you say you are. We don't actually actively manage a user database. So there are a lot of options you can select. So here I have University of Illinois. If you're public, you can also use Google. So I'm logging here. I'm logging, use the NCSA credential, and it will recognize who I am here. And then the first step is getting data. You can authorize using your own social media account. So here I'm authorizing using my X/Twitter. Yeah, but Twitter/X has been giving us a lot of headache this year since Elon has taken over. So right now we recommend you to try with Reddit. Yeah, because Reddit might be smoother. So here I am trying to search some comments in a given specific Reddit subreddit. I tried to search comments in ChatGPT subreddit, and it will give me the latest comments. And this is the preview. If you think it looks good, then you can save the data. After you save the data, actually, let me see if I can full screen this. Okay. So after you save the data, you have three options. You can download the file and then do your own analysis. And you can also find this, if you leave this page, you can find it in the past history. Here are some quick visualization that help you get some insights. You can see the post frequency by just toggling between different time intervals. And here is a way, after you leave this interface, you can find your past results. So here, this is a previous search I did. And this is the search that I just did. And here you can download and preview. So next is algorithms. Here are all the currently supported algorithms, mostly related to natural language processing and topic modeling and name entity recognition. So here I will demo two analysis. One is topic modeling. The first step is here, you can select all the data you queried using the SMILE, and you select ChatGPT. And then here is the algorithm and some parameters you can tweak. For example, you can decide how many numbers of topic you want to see them aggregated. And then this is the citation comes along with the algorithm we use. And then after you run it, since it's not real time, it might take a few seconds, a few minutes. So you can input your email address and it will let you know when it's ready. And when it's ready, you'll get an email, and then you can directly download some of the output. But for a better view, you can follow the instruction and go to your past results and see this. So this is another Python library we use called PyVis LDA, yeah, which I'll talk a little bit more later. This will help you to visualize the topic. You can do some basic things. You can see different topics, and you can also toggle the relevance metrics to, on the fly, see what are the words related to this topic. Yep. And the next analysis I want to introduce you is sentiment analysis. Yeah. So same, first step is select your data. And then for sentiment analysis, we actually support 3 different algorithms. They're all open source. We have this Vader and SentiWordNet, and the last one is the machine learning model trained to help you detect bias in sentiment classification. So here I'm trying Vader because Vader is the fastest and it's live. After submit, this time you immediately see some results. You can tag it so later you can find them better. And here is a pie chart that shows you the breakdown of the sentiment. And here is a data table that you can click the header and compare and show the most positive or negative. And yeah, on the left here is how you download. And the last part of this Smile demo is a sneak peek into the second part that I will talk about is about SMM Clouder. This is a beauty interface to help you port your data in Smile into Clouder. So here you log into Clouder and just imagine Clouder is like a Google Drive or box that has rich metadata support. As you can see, you can come up with your own metadata, as well as other customizable visualization and information extraction process. So by porting the data into Clouder, if you want to do more comprehensive data management kind of thing, so that's our recommendation to do that. And here I am going to create a data set, and then these are all the results associated with this analysis. And then I can click upload. And then this, now you're leaving Smile, you go to the Clouder interface. And this is your data now documented in Clouder. Yep. So here are some highlights of the Smile features. So this one talks about how we actually collect the social media data. We actually have a GraphQL-powered data server sits in between the user interface, the Smile server, as well as between all those social media platforms. If you want to know more about GraphQL, you can click that link to read more about it. If you want to know how we implement GraphQL, you can visit our public GitHub repository by clicking that link here. So here are some of the advantages of using GraphQL. It gives you the best part of it is because social media data are very heterogeneous. Like Twitter will give you one form of the response, and like say Reddit will give you a completely different shape. So by having a GraphQL-backed data server, we can have one clean API interface for handling those. And we can easily get predictable results based on what you queried. Then, oh, go ahead.
So
Yes.
How many social media platforms have this?
Two, Twitter and Reddit. Yes. Yeah. And we try to work with the official APIs. So we try to behave. We don't do like data like crawling or scraping or those kind of things. And next is we try to follow the standard OAuth 2 flow to let user to get data using their own credentials. If you're curious about OAuth 2, you can click this link. Yeah. So the core of Smile, I would like to say the core of Smile is nothing fancy, but a user-friendly user interface that encapsulates all those Python algorithms. So far we have 6 different algorithms. They're all written in Python. And on top of that, we have a Smile server that's wrapped around it. So user who doesn't know programming can still be able to use those algorithms. And a few highlights of that is we try to stay open. We embrace open source packages and libraries, and we try to stay Pythonic because Python has its extensive selection of open source packages that we can leverage and build upon. Some of the examples are we're using NLTK, Scikit-learn, NetworkX, and etc. Yeah, and last thing is bad analogy, but I can't help myself. So I put farm to table because we're right next to a research institution. We actually have a lot of direct collaboration with the researchers. So before they even publish their paper, they are generous enough to hand over us their algorithms so we can actually deploy them as a part of the feature. So some of the examples, if you see the automated phrase mining as well as the name entity recognition, we get them directly from the source, from the produce. Yeah. So this is our code structure, and this is a little bit boring, so I'll fly over this quickly. If you want to learn more details, you can click this. This is an example of how we do sentiment analysis, how we organize our sentiment analysis. As you can see, a lot of the code here are generic. We have generic classes that represent different interactions, like how to talk to Clouder or how to talk to Smile server, and how we talk to the RabbitMQ messenger broker, and how we handle I/O, like input and output, and those kind of, and visualization and notification. But underneath it, we have a specific implementation of different algorithms. For example, this one, we have sentiment analysis. This way, we can reuse a lot of the code for different purposes. For example, we can build with the same selection of files. We can build both containers for Clouder extraction, or we can build containers for the SMM, for the Smile. And here are some of the Python libraries that we're leveraging. So if you're familiar with NLP, we use the platform that for building Python program work with human language. And some of the analysis that use NLTK is the sentiment analysis, our natural language processing. If you click this link, it will lead you to our public GitHub repo, and you can see our code there. And next is Scikit-learn. We have a basic implementation of a machine learning feature in Smile, which basically allow you to split your data set into training and prediction. And then you can hand label your training data. You train the model using a selection of algorithms, and then you can do some basic categorization. So for this, we use the Scikit-learn package. And next, Gensum is used for topic modeling, and you can read more about how we do that. Click this example link. And last thing is NetworkX. We use that for creation of Twitter network. You can generate a retweet graph or like mentions graph by leveraging NetworkX. And there are other generic libraries we use. I didn't include. We use a lot of pandas because we clean all those data into a tabular format. So we actually use pandas to do a lot of the data manipulation. Next. So for visualization, we use a library called Plotly. It is also a Python library. The cool thing about Plotly is it is an open source Python library that can make interactive graphs, and it has a lot of out-of-box graph types. And the best part of it is like you're using Python to actually generate front-end HTML code with JavaScript embedded in this. So it alleviates the burden on your front end to be able to generate those dynamic graphs. And also, since it's the backend who generate that, you can actually store it into an HTML file, and then you can easily share this HTML file with other people. You can just drop this file to your collaborator, and they get the same exact interactive graph you have. And if you, I think they have a paid feature. If you pay for the Chart Studio, you can also connect this into that. I'm highlighting in my mouse. And in here, you can do more like graph editing. It has more capability that way. And for Smile, this is our example. We write a few basic visualization for the pie chart, for the bar chart, as well as for the network chart, because we use a lot in the Smile. Okay. This slide is listing all the resources. If you're curious, you can look at our repository, and it's nothing from perfect. Yeah, it's not very perfect, but we leverage GitHub. So if you identify any features that you want to see, or if you notice any bug, feel free to open the issue, and our development team will address them. And we're working on the documentations, so hopefully we'll have nice documentation coming up. And this is about deployment. So Smile has been a long-going project, so it actually goes through several iterations. So on the left is our past architecture. As you can see, we leverage a lot of AWS, and we also use HubZero, which is a NSF-funded science gateway. But we're moving towards a more standalone and independent design by leveraging container technology like Docker. So each of the blocks, the red box you can see is its own Docker container. And then you can use Docker Compose or like Kubernetes to orchestrate your communication. So this slide just give you a quick introduction on containerization. If you're not familiar with Docker, I'm not very good at this, but I will try. Like my analogy is like Docker is like a shipping container. And inside this container, it's like an independent environment that you have everything you need. And you can move your shipping container anywhere you want to. You can move it to this ship and you can move it to another ship, and it will still be the same. Yeah. But these these containers are independent of each other. How do we make them talk to each other? The easiest way is to use Docker Compose. It's a lightweight way to orchestrate multiple Docker containers. And of course, it has its own limitation, but I would say that is the easiest thing to start. And we actually publish our Docker Compose script. And our goal is for anyone to be able to run their own Smile or Clouder on their infrastructure. So it's like, this is like a recipe. And with this recipe and with the same material, we hope that you can reproduce the same instance. And next is Kubernetes. Kubernetes is a lot more fancier, and it's also related to the whole shipping container like analogy. So Kubernetes in Greek means helmsman and pilot. So it is a even fancier way to orchestrate different containers. It can do things like load balancing. Like if you know you're experiencing like very high traffic, it can automate it. It can be automated to scale up on the spot. Yeah, so that's Kubernetes. And next is Helm. It is still related to those terminologies. Yeah, Helms is just an easy way to help you configure Kubernetes, because Kubernetes have a very steep learning curve and have a lot of configuration quirks. And Helms is a tool that provides you a standard templates that by following those templates, you can easily configure a Kubernetes cluster. So we also publish our Helm chart. So anyone who familiar with this realm should be able to follow our Helm chart to start up our instance. So this slide has all the resources for how to deploy Smile. We publish everything to the Docker Hub, so every image should be available, and we do regular release. And next is, this is the instruction on how you can run Docker Compose. And last is how you can run it using Kubernetes. Next, I'm going to talk a little bit about Smile Clouder. You had a sneak peek of Clouder. So this is like give you more context. So first of all, why Clouder? Clouder, comparing to all those commercial tools that like Box or wait. Actually, I have a question for you all. So does anyone know what the word Clouder means? Okay, Clouder actually means a group of cats. Yeah. So it's not one cat, it's a group of cats. And so Clouder instance is not one centralized data management tool. So it's actually many instances of this tool. So that differentiates us from Google Drive or Box. So it has this flexible deployment on the cloud capability. So with this capability, we can spin off our own Smile, SMM Clouder instance. And it also has all the full data management capacity. You can upload, download, you can share your data, you can set access control on your data. And next is it has a lot of rich metadata support, like a lot of scientific data requires documentation of like metadata. So Clouder is very good at that. And the last two is the customization capability. You can write your custom information extractor, basically runs when you upload your file or upload your data or doing something that triggers those, and it can extract information from the data, from your data, and generate some meaningful like outputs. And next is custom visualization capability. So you can write your own customized visualization for a very specific purpose. Like on your left panel, you can see this one is for plant science. So they write their own previewer for that. So for our Smile instance, we heavily leveraging the last two capabilities. So here, we basically transplant the same Smile algorithms as information extractor and put them inside of Smile. So by doing that, now a user have the flexibility to upload their own source data if they have their own CSV. Sorry, they have their own tabular format of some natural language data. Now they can run the same Smile algorithm within Clouder. So this way, first of all, it's guaranteed reproducible because it's essentially the same algorithm. And secondly, it's like, bad analogy again. So it's like Smile, it's like having your computation. It's moving the data to your computation. But this is moving the computation right next to your data. So this way, you don't need to worry about, like, if you have a very large data set, you don't need to worry about the transferring. And lastly, it's an ecosystem. Clouder has its own community, and over the years, through different domains, through collaborative effort, there are a lot of Clouder information extractors available out there. So you can not only use the Smile ones, but also you can leverage other extractors. And you can also, for the output of Smile, you can also do more post-processing using other extractors. And Clowder has its own Python package called PyClowder. So this is the way how you can install PyClowder. PyClowder provides you an easier way to talk to the Clowder service. So here I highlighted some of the examples how we use PyClowder in our code. For example, we use it for file upload, and we can also use it to write the output metadata and register it as metadata to Clowder. It's just like very simple one-liner, and you have everything. And for more details, you can click this link. And here is our Clowder instance for the social media Macroscope project. This might require registration. So if you register, we will approve you in like 48 hours. And because again, I don't trust live demo, so I recorded a quick 2-minute demo of Clowder. So this is the Clowder interface. Now you can log in. You can also click the sign up if you don't already have an account. And after you log in, this shows you all the activities you have recently. And here, the dropdown are showing a few shortcuts. So this is the main interface. This is the data sets. These are all the data sets you have access to. And if you click one of the data sets, this shows you all the files belong to this data sets. And this is another way to see your own space. Space is a way that you can manage access control and data set and collection and those things. So now we're trying to create a brand new data set. Yep. And after that, you can upload files. So here I have Elon Musk's tweets scraped from, I don't know, like at least 30 days ago. So I'm just gonna import that. And for a lot of users, this is already enough. They just want a place to store their data. And on this interface, you can see there are a lot of ways you can tag the data. You can share with a certain person, or you can add your own custom metadata. But next, I want to show you how to submit the data, this CSV, to the same Smile extractors. So here are the list of extractors available for this instance. So on the top are some of the generic ones that I enabled that help you to quickly preview audio or get a file digest. And moving down, everything that starts with SMM is the Smile customized extractors. And what happened? Okay, so here, I find the sentiment analysis. My computer is sleepy. So here I find the sentiment analysis. You can decide which column you want to analyze if you have multiple columns. And here I select the same Vader algorithm and I click submit. And then on the data set, you can see the process. It gives you spin out all the logs. And once it says done, I programmed this extractor to write the output right next to a data set and right next to a file in the same data set. So now you have all the outputs deposited in the Clowder, and this is the same pie chart that you see. And here are some of the other model outputs. and you can download them this way. Okay. And for future plans, we get a lot of requests to ask us to write a Python library, a client library that we can use to interact with SMM apps. Because a lot of researchers are getting more comfortable with Python as well as Jupyter. So I think this definitely is on our list. It could be beneficial if we can provide them some Jupyter notebook examples to do like social media data retrieval or to batch submitting to analysis or batch downloading without using the interface. And next, we are always on the look for good open source Python libraries that we can incorporate. And if you have any idea in your mind, don't hesitate to reach out to us. And lastly is this year with the ChatGPT and large language modeling on the horizon, we're like eagerly looking into how we can incorporate AI facilitated knowledge discovery with social media data. And yeah, we're open to any kind of ideas. And I'd like to thank the NCSA CDDR Fund who largely support these activities. And I'd like to give some shout out to a few crucial people at the center who gave us invaluable support during the year and help us spread the news about this tool. Yeah, and this is the resource. You can email us and visit us and read more about us here. And thank you so much. Yeah. Any questions or? Yeah.
First, thank you for the very informative presentation. Well, this slide is shared.
Yes, yes, I think so. Right?
And then I have another question that we try to understand. So this is the project done by the university.
Yes, this project, this project is supported by the National Center for Supercomputing Application, which is affiliated with the university. Yeah.
And it's also an open source
Yes.
project. It's
Yes.
free of charge shared.
Yes, exactly. Yeah.
So, because you mentioned such kind of development
Right.
How you can do this.
Yes.
Mhm.
Yes. Yes.
Okay, I got you.
Exactly.
And talking about the API, what I personally use, computer API, and it's limited because you want some features. Hey,
Exactly.
so in this project, and I saw it.
Great.
We put our own credential.
Yes.
But that means access. But our own actually put our own credential runs.
No, actually, we have to register our app as a client with Twitter, now X. And then you're just using your own credential, but your limitation is tied to our app.
Oh.
Yeah, and this year Twitter, since it become X, it has drastically changed their paid plans. So we're actually in the investigation of like how much we can. So yeah, right now the basic plan is like $100 per month, and you will get for the app, not for each user. For aggregated, every user who uses app, you will only get about 10K tweets, which is minimum comparing to a few years ago. So we're actively looking into that. We have a few ideas that actually, so either for researchers who want to get more data, we can outsource that to them. They can register their clients and they just need to give us their secret, their like token password, and then we can connect Smile with their credentials. or we're actively actually looking at other things like Meta, Instagram, and TikTok. Yeah. Yeah. Thank you for your question. Yes.
Thank you, everybody, for attending. I need to break up this excellent dialogue happening here. We can continue it in the hallway. Presenters here and it's available.